It's me, Mrs. Anderson. I can't be there today, so I thought I would still give you a little lesson. I know we're done with conic sections, and you guys are going to get ready to review for the unit test, but I did want to show you a couple extra stuff. This isn't actually on the test, but I want you to know it anyway. So you have a worksheet in front of you, and you'll notice that on the top of the worksheet is a little test to, if you use eccentricity, which we know is C over A, like if eccentricity is greater than 1, it's hyperbola. If it's less than 1, it's an ellipse. And if it's equal to 1, it's a parabola. So that's one way you can look at a conic section and tell what it is. Another way is to look at the equation. And if you look here at the top of my screen, I have a big long equation, and it's actually a conic equation. And what's so special about it is that it has got a middle term. Okay, hold on a sec. It's got a middle term, this bxy. So none of if you think about the problems that we did when we completed the square, none of the problems had an xy term in it. Well, this xy term, when it is involved in a conic section, rotates the conic section. So it doesn't look straight up and down or left and right. It's tilted. So I'm going to show you today how you can actually graph this on your calculator and graph a tilted ellipse or a tilted hyperbola or a tilted parabola. So that's what we're going to do. Before we do that, you'll notice this b squared minus 4ac thing. It's the second little thing on your worksheet. That's also a test that you can use to tell if a conic section is a parabola, ellipse, or a hyperbola. So, and you'll recognize it as the discriminant from the quadratic equation. But if you take a conic section equation like this one here, okay, and you use the coefficients, and A is always in front of the x squared, B is in front of the xy term, that's the tilted term, that tells you it's tilted. C is always with the y squared, D with the x, E with the y, and then F is the constant. So if you take your b squared minus 4 and it's equal to 0, then we know it's a parabola. So if you have it equal to 0, that means you know you're going to have a parabola. If it's less than 0, then that means you're going to have an ellipse. And if it's greater than 0, it's going to be a hyperbola. So that's one way that you can test a conic section equation to see what it is. And sometimes you'll be surprised. Sometimes equations that have two squares in them, the y squared and the x squared, does turn out to be a parabola. Okay, so that's what that is. Now, what I'm going to do next is show you how you could take an equation like this and solve for y. Not many people know how to do this, so you're going to be a lucky person, because you'll know how to do it. I'm going to show you how you can solve for y, and then that way you can type it into your calculator and you can see the graph on the calculator. So the first thing we're going to do, since we are solving for y, we have to kind of break this up into like a quadratic. So if we look at our y squared term, we can say that our a is actually equal to 4. Okay. And then we want to look for our the term that has, hold on. Okay, sorry. Next, we need to find the coefficient of the linear term. And the linear term is going to be the coefficient that goes with the y's. Okay? Since y squared, the a, the 4 went with the y squared, now we have to see what coefficients go with the y term, and so that's going to be our b. So our b is going to be 4x minus 90, because that's the number that's in front of the y term. And then our c is going to be anything that's left over. So what's left over is that we have the x squared, and we have the minus 30x, and then we have the plus 450. So it's kind of weird, but in this quadratic equation, and with y being the variable, we've got our a being 4, our b being 4x minus 90, and our c being this quadratic equation in itself. So how do we write this out? We're going to write it out like y is equal to, and you remember the quadratic formula is negative b. So we have to negate the b part. So that's going to be negative 4x plus 90, that's our negative b, plus or minus the square root of b squared. So we have to take that negative 4x plus 90 and square it. That's a 90. That's your b squared minus 4 times a times c. So I'm going to squeeze this all under the radical. Okay, and that's all over 2a. So 2 times 4 is 8. So there we go. That's our quadratic equation. And you could try simplifying it if you want by squaring this binomial and working with the inside of the radical, or you could just leave it alone. So it depends on what you want to do. If you like simplifying and combining like terms, you can go ahead and do that. So now I'm going to show you a little trick. So get your calculators out, and we're going to go to y equal to, and I'm going to show you a little trick, because I think you do notice that we are going to have to graph two equations, a positive one and a negative one. So I'm going to show you a little trick how to do this. So under y sub 1, you're just going to put what's underneath the square root. And the way that you can put plus and minus, I think I showed you this before, is to put a little bracket. That's kind of an ugly bracket. Hold on a second. Let me try making that again. You're going to make a bracket, and you're going to put a 1 comma negative 1 in another bracket. Then you're going to put the square root. So then you're going to type this whole thing in. So, and then, yeah, you could just do it like this. Negative 4x plus 90 squared minus 4 times 4. And again, if you want to simplify this, feel free to do that if you don't feel like writing all this out. Okay, and don't forget, for the calculators, you're gonna get a parenthesis for the square root, so you're gonna want to make sure to end the parenthesis. Oops, and here I forgot this parenthesis. So watch your parentheses. You're gonna have a parenthesis for the 4x plus 90, and then you're gonna have a parenthesis for the quadratic over here, and then make sure you close the parenthesis for the square root. So you're gonna type this into y sub 1. Let me see if I can move this up. Hold on a second. I'm going to move this up. Okay. Now, oops, sorry. Now, in your calculators, you want to hide this equal to. You don't want that to be graphed. So go up there and hit enter so it's not darkened. And then that way you won't graph that. Then in y sub 2, watch how cool this is. You're going to have a parenthesis, okay? Then you can if you want, put the negative 4x plus 90 in parentheses. And then you're going to say just plus, and then you're going to call up your y sub 1. And remember how you do that. You go to vars, so hit the vars button, y vars, function, and then you'll see your y sub 1, and you're going to stick y sub 1 in there, which is going to take this whole equation that we typed in, and then it's going to stick that right in there. And then you're going to close your parenthesis, and then you're going to divide that all by, what did we say, 8. Now, if you do this right, you should have two graphs when you go to hit graph. And you might want to start out, you might want to zoom 6, and you may not see anything, but you'll have to fix your window. So everybody try it, see if it works out. So you're going to have your negative b, And this right here will take care of your plus or minus radical, and then make sure to close the parenthesis and then divide it all by 8. Okay, so if you did that right, if you did that right, you should get a graph that looks like this. And notice it is a parabola, even though it's got an x squared and a y squared. But it did turn out to be a parabola, and it is tilted. And that's how you can graph a conic section that's got a little tilt to it on your graphing calculators. So I hope that you liked knowing this, and I left you a little worksheet so you could practice solving, checking to see what the conic section is, and then solving for y and plotting it on your calculator, and then sketching it out. You can just make a sketch, and don't forget you might have to make your windows big so that you could see the whole graph. So that, because something that might start out looking like a parabola might end up really being an ellipse. So help each other do that. And I'm kind of laughing because I went back and replayed just to see, to make sure I said everything right, and all I could hear was my dog breathing real heavy. He was sleeping right next to me, so I apologize for the heavy breathing on this lesson. Hope that didn't interfere with anything. And I will see you guys tomorrow, and then we'll study big time for our test. Okay, guys, thanks for listening. Bye. You should get a graph that looks, let me erase that, sorry. My eraser's gone. You should get a graph that looks something like this. Now, notice the window, my window. So if you just have a 10 by 10 graph, you're not going to see much of anything. So make your X min and your X max kind of big, and you will see that you will get a parabola. So hopefully that worked out well for you, and you did get the graph. And also